Hello everyone, we are back. We're going to look at a new section for chapter 12.4. Before we start though, if you are watching this video, I want to ask you a quick question and you can send me a message and let me know what you think. I was considering skipping a day of math work and just having a Zoom meeting with anyone that wanted to participate. Rather than having an assignment, you would spend some time with me on the computer with all of us just chatting and catching up, because I really am struggling with not seeing you guys, and I think it would be kind of cool to get on and just kind of share what we've been doing and hang out for a while. So if that's something you're interested in lieu of an assignment, let me know. If I don't hear back from very many of you, we'll just keep doing the geometry videos and assignments like we're doing. I just thought it'd be nice to take one day break and kind of catch up. So send me a message and let me know what you think. Okay, so I'm going to be going over section 12.4, so you will need your workbook. But before we jump to the workbook problems that I'm going to show you, I want to demonstrate what the formula is going to be. And you guys are probably really good at this formula because you did it when you were little. It's going to be a little easier than the surface area because we're going to be dealing with volume, so how much something holds. So if you guys look at this prism right here, it is a rectangular prism because the bases are rectangles. They're parallel, congruent, and across from each other. So if you think of like a Kleenex box and you put the first Kleenex down, that Kleenex in this picture would be a 6x4, and then you would stack it up till it reaches to the top, and it would stack up 2. So when you guys were little, you used to do length times width times height. You can still do that for a rectangular prism. It would be 6 times 4 times 2. But what we're going to do is step it up and use a formula that maybe you've used, but if not, it's going to be, it's the area of the base times the height of the object. And you can use this for any prism. Doesn't matter what the bases are. And you can also use this formula for cylinders, which we're going to do, but the base will be a circle every time. So just think area of the base times the height of the object. Okay, so now you need to grab your workbook. So if you need to pause to get your workbook, we're going to be on page 131 in your workbook. We're going to do 4 quick examples. They should not take long, and they're going to be pretty easy, I think, if you just watch me work through these. I also want you to work through them on your own, and then you'll flip the workbook page over and your assignment will be on the back. Okay, so again, we're doing volume this time, so this is going to be cubic units when we get done, not surface area, and these are all prisms and cylinders. Okay, so the formula for the volume of a prism we just said is area of the base times height. So we're going to treat this the same way that we did when we were doing surface area. We're going to list the variables out to the sides. We're going to find them, and then we're going to plug them into the formula. Okay, so if I look at this prism, I have to figure out who the base is because I need the area of the base. So you're looking for the parallel congruent bases that are not necessarily rectangles. They're not rectangles if the bases are triangles. So your bases are going to be these right here. They are triangles. And so to find the area of the base, we're going to have to do 1/2 base times height because they're triangles. All right, so now when we go to find the area of one of these triangles, and I try to do the base times height, I realize that I don't know the base. So I'm going to bring this 34 over, put it on the hypotenuse, and I'm going to put an X down here because I need that to be able to find the area of that triangle. Okay, so I'm going to do Pythagorean theorem. So I'm going to go 16 squared plus x squared equals 34 squared. Okay, when I solve that, I get that x is 30. So this right here is 30, which means now I can find the area of that triangle and then stack it up to the height. Okay, so the area of the triangle is going to be 1/2. The base is 30 and the height is 16. So I'm going to type that in to get the area of the base, and that is going to be 240 for the area of the base. Now, the height of the object, you have to be very careful. When you flip this prism on its base, on this triangle base, and you stand it up, picture flipping it up, it's going to stand 22 tall, not 16, because you got to picture the height when it's actually sitting on its base. So the height is 22, just like when you did the surface area. Okay, so if I'm going to do the volume formula, it's the area of the base, 240, times the height of the object. It's as easy as that. And we're not doing 2 bases because we're literally putting 1 base in and then stacking it up to the top. Okay, so I'm just going to multiply that out, and that is 5,280. And then it's inches cubed because I'm using 3 different units here, inches by inches by inches. Okay, and you guys probably know that for volume, it's always cubic. Okay, so the second example we're going to do is a cylinder. So for the cylinder, we're going to use the same formula. So volume equals area of the base times height. So I'm going to find my variables. So my volume is going to be the area of the base times the height. So I'm going to find these variables, then I'm going to plug them in. Okay, so to get the area of the base, I notice that the base is a circle, so I'm going to use pi r squared. Okay, so the radius would be 3, so this is going to be pi 3 squared, and I'm going to leave it as 9 pi because I'm going to have an exact answer. You can do either and multiply it out if you want to. Okay, the height of the object is how tall it's standing when it's on its base. This would be the height. This is not the height because that is diagonal. So I'm going to need to find the height of the object. Okay, so this is a right triangle because this is a right cylinder. So we are going to do Pythagorean theorem. Now you might know that triple. This is a 6, 8, 10. So all you triple people out there, you don't even have to do Pythagorean theorem. If you solve 6 squared plus h squared equals 10 squared, you're going to get a height of 8. So now we know the object is 8 tall. Okay, so now we can go and plug those numbers into the volume formula. The area of the base is 9 pi, and the height of the object is 8. So when I multiply that out, I get 72 pi. So my volume is 72 pi if I want it to be an exact form, or you can have it in decimal form. The approximate answer would be about 226.2 yards cubed. I do not care which way you leave it. If you want it exact, if you want it approximate, feel free to do either. Okay, down at the bottom, I need to show you an example of an oblique prism. Okay, so an oblique prism, sometimes kids think that the formula changes, but it actually doesn't. This is going to hold the same amount as if it's standing straight up and down as if it's leaning. So it doesn't matter if this prism is oblique or not. You still use the same formula. Same for cones, not cones, cylinders. Any cylinders or prisms that are oblique, the formula, it still holds the same amount. It's kind of just leaning to the side. Okay, so for this one, we have to figure out who the base is. So I'm going to just use the bottom as the base, even though in a rectangular prism you can choose who the bases are because they have different options. I'm going to use the bottom. So volume equals area of the base times height. So I'm going to need the capital B and the H. Okay, so if I want the area of the base is a rectangle, even though it is not, even though it's oblique and not right, I'm still going to do 17 times 18 to get the area of the base since it's a rectangle, and that's going to be 306. Okay, the height of the object when it's standing on its base is 4. So this is going to be pretty easy. I'm just going to be taking 306 for the area of the base times the height of the object is 4. Kind of like when you were a kid, you used to do length times width times height. Okay, so that is 1,224 centimeters cubed. And the point of that question is just to remind you, if it's oblique, you do the same formula that you do if it's a right prism. Okay, now I added this one on here. So this is not oblique, but I brought this on here to show you an example of this. This is a prism with a pentagon base. Okay, so we're going to find the volume, which is area of the base times height. The area of the base is, we're going to be doing, whoops, I'm going to come down here and get my variables. I'm going to be doing 1/2 AP. All right, so I come over here. Oh, they gave me the apothem, and I can find the perimeter. Oh, this should be pretty easy. 1/2. The apothem is 3.4. To get the perimeter, it's going to be 5 times 5. So that's going to give me the area of the base. Now, the height of the object is going to be how tall it stands when it's on its base. Since the bases are the pentagons, it is going to be standing 8 tall. Okay, so I need to multiply out this 1/2 times 3.4 times 25, and I have that for you. It's 42.5. So now, if my volume is going to be 42.5 times 8 tall, that will tell me how much liquid this would hold if you filled it up. And so 42.5 times 8 gives you 340 millimeters cubed because it's volume. Okay, you will be flipping this over and doing problems on the back. Don't forget to message me if you'd like to take, oops, I think I just realized that that was not on the screen, so let me move that over so that you can see it. My screen goes dead every once in a while. If you want to do a video chat instead of an assignment, make sure you send me that message. Okay, talk to you later. Bye.